Okay, so today we're going to do section 1.6, which is going to talk about linear inequalities. Inequalities means they're not equal. Okay, inequality means not equal. So if we have expressions that are not equal to each other, that means they can be less than or greater than, or less than or equal to, or greater than or equal to. Right? So if we have something that's an inequality, that means it's one of these four symbols. So the first thing we're going to do with these today is we are going to graph inequalities. So for example, say we want to graph the expression x is less than 2. We want to graph x is less than 2. Now what that means is we're going to make a number line. We'll put a few numbers on it. Obviously 2 will be one of those numbers. And I'm not big on you having to make a big, huge number line, so I just made a really small one. Just make sure 2 is on there somewhere. And what we're going to do when we graph x is less than 2 is we want to show on our number line all the solutions that are less than 2. Okay? So, if I want to show on a number line all the solutions that are less than 2, am I going to be showing numbers to the left or to the right of 2 on a number line? To the left of 2, right? But is 2 less than 2? No, it equals 2, right? But it's not less than 2. So what we're going to do when we have less than or greater than is we are going to have an open circle at that number because we're not including that number. And if we have less than or equal to or greater than or equal to, we're going to have a closed circle. So closed means it's included. Open means it's not included. So since this one is just less than 2 and not less than or equal to, 2 is basically a boundary for these solutions. So we put an open circle there, and we're going to shade it to the left because that's where everything that's less than 2 is. And I don't care how bold you make your arrow, just make sure it's bold enough that I can tell which ones, left or right, are you talking about. So if you're graphing an inequality, that's what you do. Your number is your boundary. Decide if you need an open circle or closed circle. If it's less than, you go left. If it's greater than, you go the right. Okay? So let's do one more example. Let's graph the inequality. X is greater than or equal to negative 1. X is greater than or equal to negative 1. So make yourself a number line. Put negative 1 in there. And then put a number less than negative 1, number greater than negative 1. Remember that negatives are backwards on a number line. And so if it says x is greater than or equal to negative 1, do we include negative 1? Yes. So do we use an open circle or a closed circle? Closed. And so which way do we shade? To the left or to the right? To the right. Very good. So any questions about that? Okay, so those are single inequalities. We also have things called compound inequalities. What do you think compound inequalities means? Well, a compound inequality is when you have two inequalities that are connected. So we'll write that down. Two inequalities that are connected by the words and or. I know it's something we discussed in Algebra 1. Compound inequalities are connected by the words and or. So we have and compound inequalities and we have or compound inequalities. Now, and means they share something, right? And means you have something in common. Or means it's one way or the other, right? They don't have anything in common. You're either going this direction or you're going that direction. So if we're going to graph compound inequalities, this is example C. Let's say we have the inequality x is less than or equal to -2 or x is greater than 1. And we want to graph that on a number line. Well, since it's a compound inequality, I can graph both of those single inequalities on the same number line, okay? Because it's technically one compound inequality. So draw your number line. And we're going to make sure we contain these two boundary numbers. So I'm just going to go a little bit to the left and a little bit to the right. So I'm going to include -3, -2, -1, 0, 1, 2. I'll stick a 3 on there just to make it balanced. So basically what we're going to do is we're going to graph both of them on the same graph. All right? So let's just start with the first one and ignore the second one for a second. So how would we graph x is less than or equal to -2? We'll use an open circle or a closed circle at -2. Closed because it said or equal to. And which direction do we go for less than? Left. So there's x is less than or equal to -2. And then on the same number line, we're going to graph x is greater than 1. So we go to 1, and this time do we use an open circle or a closed circle for 1? Open. And we shade which way for greater than? The right. So when you graph compound inequalities and it says the word or in it, you're going to be shading in opposite directions. Okay? Or shade opposites. Okay? So any questions on how I graph that one? This should be old news. You did this stuff in chapter 6 in Algebra 1. I promise you did. All right, so that's an or inequality. So let's see an and. Now when they write an and inequality for you, they already put the variable in between the two numbers. Because like I said, they're sharing something, they have something in common. So you can read this two different ways. You can read this between, the x is between -1 and +2. It includes -1, it does not include +2. Or you can read it backwards from the x. X is greater than or equal to -1 and x is less than 2. There's two different ways we can say that. Now, what I have to remember is and means they share something. And put those numbers on a number line. So, -1 over there has an or equal to. So do we close it in or we leave it open? Yep, it's closed. It's included. And then I go to 2, and it just says less than. So is that an open or a closed circle? Open. And just remember that and shades in the middle. Okay? So or shade in opposite directions and shade together. They share the solution. So let's talk about what that means. Everything that's in red on my screen is part of a solution. All right? So is 0 a solution to this inequality? Is -5 a solution to this inequality? No, it's not. Is -1 a solution to this inequality? Yeah, it's colored in, right? Is 2 a solution to this inequality? No, because it's got an open circle. So 2 is a boundary, but it's not included as a solution. Does that make sense? Okay. So I want you guys to try these. You're just going to graph them for me. Graph them on a number line. Draw me a number line for all 4 of those, please. It takes longer to draw the number line than it is to actually figure it out, right? But I'm not too picky. You don't have to draw them super big or super long. Okay, so number 1, x is greater than -5. So here's a number line. Now, negatives, remember, go backwards, right? So So lower than -5 is -6, higher than -5 is -4, right? So does -5 get an open circle or a closed circle? Open, because it doesn't say we're equal to. And which way do we shade for greater than, left or right? Greater than, we shade which way? To the right. So raise your hand if your number 1 looks something like my number 1. Open circle, shaded to the right. Any questions? All right, number 2 says x is less than or equal to 3. So make yourself a number line, stick a 3 on there, put a 2 and a 4 with it. So does 3 get an open circle or a closed circle? Closed, because it says less than or equal to. And for less than, do we shade to the left or to the right? Left. So raise your hand if you got number 2 right. All right, so 3 and 4 are compound inequalities. Now, which one is an and which one is an or? 3 is an and 4 is a or. Guess how you know the difference? If it says or, it's a or. Or always says or. So if it doesn't say or, it means it's an and. Right? So or. Okay. I have no idea what it's doing, but maybe I'm recording both of them. So say we have one that's a little bit more complicated. I want to see what this is doing. Y'all care? I think we're good. All right. So let's solve this one for x. So again, we're going to use the same processes as we do when we are solving equations. So how are we going to do this? Very good. Subtract 21 on both sides. And then we'll get 3x is less than or equal to what? It's 45. Yeah, 24. And then we'll do what? And the answer is, the answer is not 8. It's x is less than or equal to 8. Okay, the symbols are as important as the answer. Okay, it's not just 8, it's anything that's less than or equal to 8. All right, I really don't know what this is doing. We'll just see if it works. All right, let's try one more. 5x minus 7 is less than or equal to 6x. Now, on a problem like this, whether it was an equation or an inequality, if I've got a variable hanging out over here by itself, I'm going to move the other variable to that side. So I am going to subtract 5x on both sides. And so that gets me -7 is less than or equal to 1x. Now, we don't like to leave inequalities written backwards like that. We want the variable to come first. So what you'll do at the end is you will just flip everything, and when you flip around the answer, you need to flip the inequality symbol as well. So make that less than or equal to -7. Any questions about that? You're right, because I said to flip it, didn't I? Sorry about that. Yes. So when you want to rearrange an inequality so that the variable comes first, you need to flip your inequality symbol and then reverse the order of the variable and the answer. Does that make sense? Okay. Thank you for correcting me. Okay. Now let's do sum with the variable on both sides. Example I, let's do 5x plus 2 is greater than 7x minus 4. Now we did this with equations yesterday, right? What do we do when we have a variable on both sides of the symbol? We get them together, don't we? Right? So what do y'all want to do to get your x's together? Yeah, I'm going to subtract 5x on both sides. So I'm going to get 2 is greater than 2x minus 4. And then I'm going to move everything away from the x. So I'm going to add 4 to both sides. What is 2 plus 4? So 6 is greater than 2x. Divide by 2. I'm getting 3 is greater than x. I'm not going to leave my answer like that. What is my correct answer? Right. Flip everything. Any questions on that? Very good. Let's do one more, and then you guys are going to try some. And then we'll almost be done. All right, same type of thing here. I have an x on each side of my symbol. So somebody tell me how you want to get your x's together. Yep, you can subtract 4x or you can subtract 6x. Either way. So that's going to be 3 is less than or equal to 2x minus 5. And then we want to get the x by itself. So how can we do that? Yep, add 5 to both sides. 5 plus 3 is 8. So 8 is less than or equal to 2x. Divide by 2. And what do we get? 4 is less than or equal to x. Do we leave the answer like that? No. What's the right answer? X is greater than or equal to 4. Swap it around so the variable comes first. We want our inequalities in terms of x. Okay. You guys are going to try some. Equal to negative 14. And 3 minus x is greater than x minus 9. Y'all try those too. Oops, sorry. All right, quite a few of you look like you are finished. So if you are, go ahead and check your answer to the neighbor. They are also finished. Okay, so on number 1, how did we solve it for x? Yep, you want the middle to have nothing but an x in it. So subtract 7 on both sides. Those cancel, and I'm getting negative 8 is less than 2x is less than what? 12. And then you do what to get x by itself? Divide by 2 everywhere. And I'm getting negative 4 is less than x is less than what? 6. Now, if you make a number line, and if these numbers are spread out kind of like this, if you do it by 2s, it's not going to hurt my feelings. Does that make sense? But is this going to be, is this an and or an or? And how do we shade ands? In the middle, right? So does negative 4 get an open circle or a closed circle? Open. Does 6 get an open or a closed circle? Open, and we shade it in the middle. So raise your hand if you got something like that for number 1. Good job. And how do we do ORs? Just solve them both, right? Stick OR with your answer. All right, so on this one, we're going to add 1 to both sides. What's negative 1 plus 1? So 3x is less than 0. Divide by 3. And then x. What's 0 divided by 3? Is 0. X is less than 0. I'm going to go ahead and put OR with my answer so I don't forget it. And over here, I'm going to subtract 5 on both sides. I get 2x is greater than or equal to 6. Divide by 2. And x is greater than or equal to 3. Did y'all get that? Y'all get that? And then on the number line, how do we shade ORs? Yeah, in opposite directions. So does 0 get an open circle or closed circle? Open, shade left. Does 3 get an open circle or closed circle? Yeah, it says or equal to, so it's closed. We shade to the right. So any questions on today's lesson at all on inequalities? You good?